What we have here is an example where we're going to be factoring by grouping. Now on the left you can see I have the steps laid out in words to kind of guide you, so if you for whatever reason need to read as well as see the process, you have that visual cue as well. So the first step is we're going to put brackets around the first two terms and the last two terms. This is the grouping that we're doing. So we're grouping the first two terms and we're grouping the second two terms. What we're going to do next is we're going to factor out the GCF from each set of brackets or each group. So the GCF of 4x cubed plus 20x squared is going to be 4x squared. Now, because we're factoring out the GCF, we need to say what we have left over. And we're going to have an x plus 5 left over, because when I multiply 4x squared times x, I get 4x cubed. When I multiply 4x squared times 5, I get 20x squared. I'm going to erase this. On. Now, we also have to find the GCF from the second group. And the GCF of the second group is going to be a positive 3. Now, when we factor out the positive 3, we have the same thing left over inside the parentheses, and that's going to be an x plus 5. Now, the last part for factoring by grouping is to actually just rewrite your two binomials. Now, the first one is the easy one to spot because we have this repeated binomial. We're going to write that one time as part of your factored form of the answer. Now, to get the second binomial, we're going to use these terms that are in front of that x plus 5. So the 4x squared is going to be the first part, and the plus 3 is going to be the second part, or the second term, to our second binomial. So our factored form for the answer is going to be x plus 5 times the binomial 4x squared plus 3. So let's take a look at a second example. (3x cubed minus 9x squared plus 4x minus 12. Now we're going to follow this process the same way. We're going to start by grouping the first two terms and the last two terms. And now we're going to find the GCF of the first two terms, and that's going to be 3x squared. Well, what we have left over is going to be an x minus 3. Now the GCF of the second two terms is going to be a positive 4. And what we have left over here is going to be, again, an x minus 3. So now this repeated binomial, I usually like to write that binomial first. And then I'm going to use the term in front to create my next binomial. So I'm going to have a 3x squared plus 4. So now let's proceed to a second type of factoring problem, and that's going to be factoring trinomials. So that's going to be something of the form ax squared plus bx plus c, but we're going to focus on the situation where that number in front, that a value, is not going to equal 1. So if we're looking at the example 3x squared plus 10x plus 8, the first thing we're going to do, as strange as it sounds, is actually multiply the a and the c. So if you need a reminder, a is the number in front of the x squared, b is the coefficient of x, and c is the constant. So we're going to multiply the 3 and the 8, and clearly we're going to get 24. Now what we're going to do is we're going to find two numbers that multiply to give us this a times c value, which is the 24, and to add to get that middle coefficient, the b value, as well. So sometimes I write myself a little chart like this to help me organize this idea. So I'm looking for two numbers that multiply to give us 24 and add to give us 10. So I'm going to put down a couple factors, their possibilities. So we could look at 1 and 24. Well, clearly if I add them, I'm not going to get 10. That's not a good set. I can look at 2 and 12. Now if I was subtracting them, I could get 10, but since I have to add, this isn't going to work, because when I add them, I'm going to get 14. We can look at 3 and 8, and again, that's not going to work, but it seems like we're getting closer because we're now at 11. So this last set is going to be the one that works, clearly, and that's going to give us a sum of 10. So I'm going to use these two numbers here for my next step. So what I'm going to do is split the middle term, this 10x right here, in using the numbers that I just found, this 4 and this 6. So I'm going to rewrite this as 3x squared plus 6x plus 4x plus 8. So if I'm looking at this and I was trying to go in the reverse direction, go up and combine these two things, I would get 10x. But I did all this process here to split this 10x into two terms, because now what we're going to do is factor by grouping. So I'm going to group the first two terms together, and I'm going to group the last two terms together. The GCF of the first two terms is going to be a 3x. And what we have left over in the parentheses is going to be an x plus 2. When we find the GCF of the second two terms, that's going to be a 4. So I'm going to write down plus 4, and then in parentheses afterwards I have an x plus 2. And now just like before, I'm going to write my final answer, the two binomials. That's going to be an x plus 2 and a 3x plus 4. Let's try one more example. That's going to be 3x squared plus 4x minus 7. So remember, we're going to multiply the a value and the c value. So 3 times a negative 7 is going to give us a negative 21. And then our b value is the 4. So I'm now looking for two numbers that multiply to give us a negative 21 and add to give us a 4. That's going to be a 7 and a negative 3. So let me double check. 7 times negative 3 is 21. 7 plus negative 3 is going to give us a positive 4. So I'm going to split this middle term. So I'm going to have 3x squared plus 7x minus 3x minus 7. Now we're going to group this polynomial here. So the first two terms and the second two terms. The GCF of the first group is going to be just an x. And what I have left over is going to be a 3x plus 7. Now for the second two terms, it might be tempting to say, well, the GCF is a positive 1. But if we do that, we end up with a negative 3x minus 7, and these two binomials don't match. So because they don't match, we don't want to take out a positive 1. We actually want to take out a negative 1. And more often than not, it actually is beneficial to always take out a negative if you have that as an option. So for here, I'm going to take out the negative 1, and what I have left over is going to be a positive 3x plus 7. So now that my two binomials match, or at least the two binomials inside the parentheses match, I can write my final answer, which will be a 3x plus 7 times an x minus 1, and we're done.